substitution. So we're still talking about systems of equations. And again, if you remember from our graphing, we're looking for an ordered pair, two numbers that make both of the equations true at the same time. So graphing is pretty straightforward because you can really see where that ordered pair is. You can look on the graph and see exactly where those two lines meet each other. The problem with graphing is that sometimes it's just not really efficient. So let's say maybe your numbers are really big. Maybe your ordered pair is 25 and 72. Who wants to make a graph that's that big? So that doesn't work. Maybe your numbers are fractions or decimals, which are harder to put onto a coordinate plane, especially if you don't know that's what you're going to be looking for. So we're going to look at two other methods of solving systems of equations that don't involve graphing. And the first one we're going to look at is substitution. So remember that a system of equations is two or more equations using the same variables. And a solution for that system is going to be an ordered pair. So we're looking for numbers that stand for those variables. In this case, we're looking at two variables, so we'll have two numbers in an ordered pair. So substitution is just like it sounds, substituting. And if you think about substituting something, if you're making a recipe and you substitute one item in for another, it's taking its place. So we're going to take something out and substitute something else in its place, something else that is equal to it. So if I'm making a recipe it includes sugar in there, and I don't have any sugar, I don't want to put mustard in there in place. Those are not equivalent to each other. But I could put something else that works the same as sugar. That would work just fine. So we've got 4 steps here, and we're going to go through those 4 steps for 2 different systems of equations. So the first one we're going to use is y equals 3x minus 4. And 5x minus 2y equals 10. So this is our system. These are the 2 equations we're going to work with for this first one. So the first step, we're going to solve one of the equations for one of the variables. Remember, solving for a variable means getting that particular variable by itself. And we're going to use substitution when we see that it's really easy to get one of the variables by itself. So you want to look at both of the equations and see, is one of these equations, if I tried to get a variable by itself, would it be really easy? Like one step. If you have to do more than one step, I wouldn't recommend substitution for that system of equations. So these two systems, if you'll notice, 5x minus 2y equals 10, I've got numbers in front of everything. Ugh, that'd be kind of ugly to get x by itself or y by itself. But this first equation already has y all by itself. So I'm going to work with this first one to start. So since this already has the y by itself, I know that y is the same as 3x minus 4. So remember I was talking about my recipe, and I was saying if I'm going to take sugar out, I'm going to put something in its place that's equal to it. That's what's going on here. I'm going to take a y out, and I'm going to substitute in its place something that's equal to it. In this case, 3x minus 4 is equal to the y. They represent the same amount of stuff. So 3x minus 4 is going to be this magic piece here that I'm going to substitute in for the y. All right, step 2, we're going to substitute the expression from step 1, this 3x minus 4, into the other equation and solve. So I'm going to take my second equation. This is the one I'm going to use as my substituting one. I'm going to take my second equation, 5x minus 2y equals 10. Now notice here is where my y is, and I put the y in parentheses, just like I did with this first equation here. Where the y is, I'm going to take the y out, and in its place, I'm going to put that 3x minus 4. Since the y is equal to the 3x minus 4, I can take the y out and put 3x minus 4 in its place, substituting. You'll notice what happens now is that I don't have an equation with 2 variables, I have an equation with 1 variable, and we know how to solve equations with 1 variable. So from here, I'm going to solve. So from here I see my 5x minus 2, and then in parentheses 3x minus 4 equals 10. I need to use my distributive. Don't forget this negative is stuck to the 2, so it's 5x minus 6x, and then that negative 2 times negative 4 gave me positive 8. Next I'm going to combine like terms. I get negative 1x plus 8 equals 10. Then I'm going to try to get this x by itself by subtracting 8 from both sides. So I get negative x equals 2. I don't want negative 1x, I want positive 1x. So I'm going to divide each side by negative 1, and I ended up with x equals negative 2. So if you remember, our solution is an ordered pair. So I need 2 numbers. I've only got one of them. I have the value for x, so I'm halfway there. Third step, substitute the value from step 2 into one of the original equations and solve. So I got from step 2 here that x was equal to negative 2. So I'm going to take either one of these equations, because remember I'm looking for an ordered pair that works for both of them. So I'm going to get the same y value, whichever equation I use. So I'm going to use the one that's a little bit friendlier to work with, which this first one is. So I'm going to take y equals 3x minus 4. I'm going to take out the x, and I'm going to replace it with negative 2, a little more substitution here. Follow my algebra. 3 times negative 2 is negative 6. Negative 6 minus 4 gives me negative 10. So I have an ordered pair here, negative 2, negative 10. My final step is to identify that solution as an ordered pair, negative 2, negative 10. And I can do what I did with my graphing. I can take these numbers and plug them back in, and they should both work. 3 times negative 2 is negative 6, minus 4 is negative 10. That works. Let's try this more complicated one, though. 5 times negative 2 is negative 10, minus 2 times negative 10 is negative 20, so that's minus a negative, so that's plus. So I have negative 10 plus 20, which gives me positive 10. So that ordered pair works in both of them. All right, we're going to do one more here. Same 4 steps. So the steps are not any different here. I'm just going to work with a different system. So this is the system I'm going to work with here. X minus 2y equals negative 3, and 3x plus 5y equals 24. So my first step, solve one of the equations for one of the variables. So neither of these equations already has a variable by itself, as our first system did. So we're going to have to do a little bit more work before we can go on to step 2. So I want to take one of these equations and get a variable, x or y, doesn't matter, by itself. So the second equation, that's got a lot of work to it to do that. But notice here that the x has a 1 in front of it already. So I won't need to divide by anything if at the end if I get x by itself. So that's really what I want to do. I want to look for a coefficient of 1 somewhere and get that variable by itself. So here's a coefficient of 1. So if I get rid of this subtracting 2y, I'll be good to go here. So I'm going to add 2y to both sides, and I get x equals 2y minus 3. So x equals 2y minus 3. So here's that expression that I'm going to substitute into the other equation. So step 2, substitute the expression from step 1 into the other equation and solve. So I'm going to take this other equation. I'm working with x here. So here's my x. So out comes the x, and in its place goes 2y minus 3. Use those parentheses, please. That'll remind you that you may need to do distributive, which we do here. So again, notice I've only got the variable y. So now I do distributive. I get 6y minus 9 plus 5y equals 24. I'm going to combine like terms. I get 11y minus 9 equals 24. I'm going to start to isolate the y here. So I'm going to add 9 to both sides. I get 11y equals 33. Divide each side by 11, and I get y equals 3. So again, I'm halfway there. I have the y value of my ordered pair, my xy ordered pair. Now I need to go to step 3 and substitute that value that I found here into one of the equations, your choice, and solve. So I know y equals 3. Again, I used this first equation just because it had a coefficient of 1 in there. It was a little friendly to work with. You can work with either one, whichever one seems the friendliest to work with for you. So I took my x minus 2y equals negative 3. I took out the y and put 3 in its place. So I have x minus 2 times 3 equals negative 3. That's x minus 6 equals negative 3. I'm going to add 6 to both sides, so I have x equals 3. So I have my two numbers, y equals 3, x equals 3. I'm going to identify the solution as an ordered pair. So I come up with 3 as my ordered pair. I'm going to check them, just mental math. 3 minus 2 times 3, that's 6. 3 minus 6 equals negative 3, yes. 3 times 3 is 9. 5 times 3 is 15. 9 plus 15, yep, that equals 24. So this ordered pair works in both of those equations, which is what our solution should do.